The most important thing about determining what it is seeing if the elements involved are metals versus non-metals. So the first one we have in the column, which do a sample, is when fluorine and fluorine come together. So when we have F and F coming together. So guys, is fluorine a metal or non-metal? So you guys look at the periodic table for F.
It's a non-metal.
Right, it's located right here, so it's a non-metal. So when two non-metals come together, that's going to be a covalent bond. So you guys can fill in your T-chart on your worksheet under types of electrons under covalent. You can type in or write in non-metals. And then whereas if there is a metal involved, it'll be ionic. But we'll come to that once we finish going over covalent. So some different types of properties of covalent bonds is what happens to the electrons. So as you guys can see in your covalent bond table, when fluorine and fluorine comes together, something happens especially with its electrons. So going over the steps and determining what the bonds are, you first determine how many valence electrons does each atom have. So fluorine, if you guys look at the periodic table, how many valence electrons does it have? Yes, Brenda?
7.
Right, 7. So as you can draw, remember we learned 1, 2, 3, 4, 5, 6, 7. You can do that with the next one as well. 1, 2, 3, 4, 5, 6, 7. And then you can look at the second one is how many electrons do the atoms need to complete its outer shell in order to get 8?
They each need 1 electron.
One more. So you guys can think of, it's a simple equation. So 8, which is the octet rule, minus how many valence electrons they have, which is 7, equals 1. So each needs 1 more. And so as you can see, each of the fluorine has one lone electron. So if you can see, these two can come together, and if they share electrons between the two of them, each one has 8 electrons if it comes together in bonds. And so as you can see, these electrons are being shared together, and so they each has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it's completed the octet rule. So in this column, you can see when non-metals bond together, it's a covalent bond, and electrons are being shared. So any questions so far, what we've gone over? So can I get a thumbs up if you guys following me? Thumbs down if you're not sure? Great, so we'll keep going. So, now that we've gone over covalent bonds, we'll go over ionic. So, as an example is when potassium and bromine come together. So, K and Br. So, going over the steps in determining which are bonding, how many valence electrons does each of these elements have? So remember, look at the periodic table. So we'll go to the first one. How about potassium, K? Which column is that in? Yeah, Josh?
It has 1.
Right, so it's in right here. So it's in this column, so it's 1 valence electron. So we can draw that there. And now how about bromine? Which column is bromine in? Yeah, Brenna?
It's under the fluorine, so it has 7.
In the 7 column, right. So it has 7. So we write in 1, 2, 3, 4, 5, 6, 7.
I have a question.
Yes.
I'm confused because bromine is a non-metal, right? So
Right.
I thought non-metals did covalent bonds.
Right, but where is potassium?
Right, potassium's metal.
Right. And so we have a metal bonding with a non-metal. And so it doesn't have to be 2 metals coming together, but an ionic bond is between metals and non-metals. No, perfect. And it's a great question. It's a good thing that I left out. So, but the important thing is, unlike covalent covalent bonds, which includes no metals whatsoever. Ionic bonds do include metals. So you basically went to my, my second point there. So kind of labeling which one's which. So we kind of went over, so bromine is a nonmetal. So nonmetal. Whereas potassium, as we see, is in the metal category, is a metal. So if we're going to look at our T-chart, since it's a metal, we see is an ionic bond. Now here you come to the different properties. Whereas covalent bonds, the electrons are shared. For ionic bonds, they're going to do something different. So as we look over here, if you look at the different properties of the two different atoms, with the metals, they don't hold on to electrons very, very tightly. So they're ready to get rid of it much more easily. Whereas bromine is so close to getting heat, it's ready to pick up different electrons as much as possible. So since the different electronegativities, bromine is going to steal this electron from potassium and take it for itself. So thus giving this one 8, and potassium will give up 1. So then bromine will 8 in total, and potassium will then have will get rid of 1, so in its outer shell, it'll sink down to having 8 together on the inner shell. So they're both in the most stable form. But, so as you can see, this one, whereas over here, it was being shared, over here, electrons being transferred, it's being given up. And so as you guys can fill in your T-chart here, the electrons are being transferred. And that's the case with any ionic bonds. The metal is always willing to give up its electrons, whereas the nonmetals want to take it in so it can reach 8 electrons by doing so. So any questions so far? Great, so now we're kind of going over naming and like writing out the names for the different bonds. So when you look at the two different covalent bonds, since they're just coming together, you can draw it as F dash F. As you learned the other week, you can just draw bonds as a dash. But since there isn't an equal sharing of electrons between ionic bonds, you also bring in charges. So as we learned before, what charge does an electron have? Yeah, Josh? Negative. Right. Electrons have a negative charge. So when bromine is taking on another electron, which is a negative, does bromine become positive or negative? Negative, right. So if the baseline is here, because a negative, it drops down, so it becomes negative. So you're going to draw BR, it took on one additional one, so it's -1. So if bromine became negative, so it took on an electron, what happens to potassium when it gave up electron? Does it become positive or negative?
Positive.
Positive, right, because it's less negative, so it's positive. So that's +1, since it gave it up. So that's how you would write out the bonding between potassium and bromine. It would be K+1 and Br -1. And as you guys know, opposites attract. So since this is positive and this is negative, the difference in charging actually causes them to bond together. So that's what forms this bond. Whereas the bond here is between the shared electrons. So any questions of kind of what we've gone over? So as we kind of recap what we've learned, a way to distinguish between the different types of bonds is by looking at what type of elements are happening in the bonding. So the first thing to look at is you're looking at your two different elements is to determine if they're metals or nonmetals. And if they're both nonmetals, then you can look at your chart, that'd be covalent bonds. And if there's no metals involved, electrons will be shared. Where if there is a metal involved, like we have with potassium, then it'll be ionic bonds, and electrons will be transferred.